Hello friends. In our previous video, we have seen few practice problem on factorial notation and basic concepts of permutation. In this video, we'll see advanced problem on permutation and combination. Problems based on permutation when all the objects are not distinct. How many different words can be formed with the letters of the word Allahabad? In how many of them do vowels occupy even positions, and we also need to find out in how many of them both L do not come together. Now initially we will observe the word Allahabad. How many letters are there? There are total 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are total 9 letters in the word Allahabad, in which there are 4A, 2L, 1H, 1B and 1D. So if we consider repetition, A is repeated 4 times and L is repeated 2 times. So number of different words formed by using all the letters of the word given. Hence the number of different words formed by using all the letters of the given word would be 9 factorial upon 4 factorial into 2 factorial. Now 9 factorial we will split up to 4 factorial, that is 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial and 2 factorial. Now this 4 factorial will get cancelled. So we will have 9 into 8 into 7 into 6 into 5 divided by 2, that is 7560. So we can create 7560 words without any restriction. Now there is a first question asked, that is first condition asked in this problem is in how many of them do vowels occupy even position. Now we know that there are total 9 letters, that means 9 places are there. Now out of 9, 4 places would be even. So on the second position, fourth position, sixth position and eighth position, what we need to do is we need to place only vowels. Now how many vowels are available with us? There is 4 A's are available and rest of the words are L, H, B and D. These are not vowels. So we just have 4 A's which are to be placed at the 4 even places. So now these 4 vowels can be placed on 4 even places in only one way. So total number of words formed would be 1 into 5 factorial upon 2 factorial. Now why 5 factorial upon 2 factorial is because out of 9 places, now 4 places are already preoccupied by vowels. So there are remaining 5 places, and these 5 places are to be filled with 2L, 1H, 1B and 1D. Now H, B and D are unique, but L is repeated. Hence number of words formed will be 5 factorial upon 2 factorial into 1, that is 5 into 4 into 3 into 2 factorial divided by 2 factorial. Now again this 2 factorial will get cancelled. So 5 into 4 into 3, that is 60. So to answer first question, that is in how many ways do vowels occupy even position, is in out of total 7560 words, there are 60 such words where vowels occupy even position. Moving to second condition, in how many of them both L do not come together. Let us take both L are together. If we calculate words in which both L are together, and from that we can simply find out the words in which both of these L's are not together. Now in order to calculate this condition in which both L are together, we will consider that these both L are together as one unit. So how many letters will be available with us? That is 4A, 1H, 1B, 1D, and this both LL as 1 unit. So, number of words having both L together will be now 8 factorial, that is 4, 5, 6, 7 and this 1 unit as 8. So, 8 factorial. Now, in this 8 factorial again this 4A are together. So, ultimately number of words are 8 factorial upon 4 factorial, that is 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial. Again this factorial 4 factorial 4 factorial gets cancelled. So 8 into 7 into 6 into 5 is equal to 1680. So there are 1680 words in which both L are together. Hence, number of words in which both L are not occurring together is equal to this total number of words, that is 7560 minus this 1680, that is 5880. So, there are 5880 words in which both L will not be together. Find the number of arrangement of the letters of the word independence. In how many of these arrangements do the words start with P? Do all the vowels always occur together? Do all the vowels never occur together? And do the words begin with I and ends with P? Now there are 4 separate conditions which we need to calculate. In the word independence, how many letters are there? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 11, 12. So there are total 12 letters, out of which N appear 3 times, E appear 4 times, D appear 2 times and rest are the unique letters. So without any condition, how many words we can make is 12 factorial upon 3 factorial into 4 factorial into 2 factorial. Now initially we will solve this. So 12 factorial we will split it up to 4 factorial, that is 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial as it is. 3 factorial we will split as 3 into 2 and 2 factorial as it is. So now again this 4 factorial will get cancelled. This 3 into 2, 6 into 2 is 12. So this 12 and 12 from the numerator will get cancelled. So we have 11 into 10 into 9 into 8 into 7 into 6 into 5, that is 16,63,200 words we can make. Now first condition is, do the words start with P? Now P is not repeated. P is appearing in the word independence. P has appeared only once. So when the words start with P, so out of 12 there will be just 11 letters to be filled by 11 places. So total number of such words which starts with P will be equal to 11 factorial upon 3 factorial into 4 factorial into 2 factorial. 3 factorial for N which has appeared 3 times, 4 factorial for E which has appeared 4 times and 2 factorial is for D which has appeared 2 times. So if we solve this, 11 factorial upon 3 factorial into 4 factorial into 2 factorial, again we will split this 11 factorial up to 4 factorial, that is 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial into 3 into 2 into 2. So 3 factorial have split into 3 into 2. Now if we solve this, 1,38,600. So ultimately we can create 1,38,600 words to start with P. Next condition, do all the vowels always occur together? Now in the word independence, how many vowels are there? There are 4 times E and 1 times I. That is, there are total 5 vowels which are there in the word independence. Now what we want is, we want these 5 vowels always to come together. So there we can consider one unit out of these 5 vowels. Now these vowels can be arranged in this unit particularly in 5 factorial upon 4 factorial into 1 factorial, that is in 5 ways. Now this single unit along with remaining 7 letters will be arranged in 8 factorial upon 3 factorial into 2 factorial. So 7 other letters and this one unit is total 8, and n has appeared 3 times, so 3 factorial, and d has appeared 2 times, so 2 factorial. So total such arrangements are 8 factorial upon 3 factorial into 2 factorial. Now we will solve this. 8 into 7 into 6 into 5 into 4 into 3 factorial upon 3 factorial into 2. So again this 3 factorial will get cancelled. So we have 8 into 7 into 6 into 5 into 4 divided by 2, that is 3360. Therefore total number of ways will be, now this 3360 into 5, that is 16,800 ways. So there will be 16,800 words in which all the vowels will occur together. Now there is third condition, do all the vowels never occur together. Now we have already calculated number of words where all the vowels are together. So number of ways in which all the vowels are not together is equal to total words minus the arrangements where vowels are coming together. That is 16,63,200 minus 16,800 will give you 16,46,400. And the last condition is, do the vowels begin with I and end with P. Now when the words start with I and ends with P, that means out of 12, two positions will be fixed. So remaining 10 positions will be occupied by 10 factorial upon 3 factorial into 4 factorial into 2 factorial ways. So we will solve this. 10 factorial for 10 places. Now 3 factorial for n, 4 factorial for e, and 2 factorial for d. So 10 factorial upon 3 factorial into 4 factorial into 2 factorial. Now we will solve this expression, that is 10 factorial we will split up to 4 factorial, that is 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial as it is. 3 factorial we will split as 3 into 2 and 2 factorial will split as simply 2. Now this 4 factorial will get cancelled. So remaining expression will give result as 12,600. So there are 12,600 words in which the word will start with I and ends with P. Moving to next problem. If all the letters of the word again be arranged as in a dictionary, what is the 50th word? Now the given word is again. How many places are there? There are total 5 places. So how many total words we can make by rearranging the letters of this word again is 5 factorial upon 2 factorial. Total 5 places and a is repeated twice. So 5 factorial upon 2 factorial is equal to 60. So ultimately we can make 60 words, and out of these 6, let's suppose if these 60 words are arranged in the form of dictionary, then what would be the 50th word that we need to find out? Initially there will be, these words are arranged in the form of dictionary. That means all these words are arranged alphabetically. So initially there would be words with the letter starting from A. So first of all we will calculate how many words will be there which can start from A. Now, how many words are there? There are 4 factorial words, that is 24 words which can start with A. Now, after A, next letter in sequence is G. So, how many words we can form which can start with G is again 4 factorial upon 2 factorial. 4 factorial is for remaining 4 places and divided by 2 factorial because A is repeated twice, that is 4 factorial upon 2 factorial is equal to 12. Now 24 plus 12 is equal to 36, but we need to find out 50th word. So we will go with the next letter in sequence. So after G there would be I. Now how many words can be there which are starting with I? Again similar to G, 4 factorial upon 2 factorial, that is 12. Now in a dictionary there would be initially 24 words which have started with A, then 12 words which have started with G, then 12 words which have started with I. So how many total words are there? So 48 words are already there. After that, what would be 49th word now? Now this 49th word would start with N. So after N it would be then A, again A, and G and I. But we need to find out 50th word. So it would be NAA, and now instead of GI it would be IG. So ultimately in the dictionary which would be the 50th word is NAAIG. Understood? So let's suppose if we need to calculate 51st word, then it would be NAGA and I. Moving to next problem. In how many ways can the letters of the word assassination be arranged so that all the S are together? Now it's a very big word. So total number of words in this word, so total number of letters in this word assassination is 13. Now you need to count all the letters very carefully in this word because many letters are there which are repeated. So A is repeated 3 times, S is repeated 4 times, I is twice, N is also twice, and T and O appear only once. So total number of arrangements will be 13 factorial upon 4 factorial for S, 3 factorial for A, 2 factorial for I, 2 factorial for N. That is 13 factorial upon 4 factorial into 3 factorial into 2 factorial upon 2 factorial. Now we will solve this expression. So 13 factorial is equal to 13 into 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial. 3 factorial we will split as 3 into 2 and 2 factorial is 2 into 2. So this 4 factorial will get cancelled. Then this 3, 2, 2 and this 12 will get cancelled. This 2 ones are 2, 2 3s are 6. So we have 13 into 11 into 10 into 9 into 8 into 7 into 3 into 5 divided by 1, that is 1,08,10,800 words are there. Now we need to calculate the words in which all the S are coming together. So how many times S is repeating? So S is repeated 4 times. So out of these 13 letters in this word, there are 9 letters and S has appeared 4 times. So now what we will do is we will consider all these 4 as one unit. So number of words would be 10 factorial upon. Now again for the repetition, we need to consider A has appeared 3 times, N is twice and I is also twice. So 10 factorial upon 3 factorial into 2 factorial into 2 factorial. Now if we solve this expression, we get 1,51,200 words. That is, we can create such word in 1,51,200. That is, we can create such words in 1,51,200 ways. How many 4 digits can be formed with the digit 1330? How many digits are given? There are 4 digits. 1, 3 is repeated. So 1, 3, 3 and 0. So how many 4 digit numbers we can create is 4 factorial upon 2 factorial. That is 4 factorial upon 2 factorial is why? Because 3 is repeated twice. So 4 factorial upon 2 factorial is 12. But we cannot consider 0 at thousands place. Hence we have to eliminate such words. So how many numbers will be there in which 0 has appeared at the first place, that is thousands place, that is 3 factorial upon 2 factorial. That means 3 words. So ultimately how many such numbers we can create is 12 minus 3, which is equal to 9. Hence we can create total number 9 numbers in which 0 is not there at the thousands place. That is, there are 9 numbers which have 4 digits. Now we will solve few problems based on combination. Evaluate 10C8. Now we know the formula that NCR is equal to n factorial upon r factorial into n minus r factorial. Now we need to calculate 10C8, that is n is equal to 10 and r is equal to 8. Hence 10C8 is equal to 10 factorial upon 8 factorial into 10 minus 8 factorial. That is 10 factorial upon 8 factorial into 2 factorial. Now we will split this 10 factorial up to 8 factorial. So 10 into 9 into 8 factorial upon 8 factorial into 2 factorial. So 8 factorial will get cancelled. That is 10 into 9 upon 2, which is equal to 45. We'll move to next problem. Evaluate 100C98. Now once again we'll write down the formula. NCR is equal to n factorial upon r factorial into n minus r factorial. Now here also n is equal to 100 and r is equal to 98. So NCR is equal to 100 factorial upon 98 factorial into 100 minus 98 factorial. That is 100 factorial upon 98 factorial into 2 factorial. Now we will split this 100 up to 98, that is 100 into 99 into 98 factorial upon 98 factorial into 2 factorial. Now again this 98 factorial will get cancelled. So we have 100 into 99 upon 2, that is 4950, 4950. We'll move to next problem. Evaluate 52C2. NCR is equal to n factorial upon r factorial into n minus r factorial. So 52C52 is equal to 52 factorial upon 52 factorial into 52 minus 52 factorial. that is 52 factorial upon 52 factorial into 0 factorial. So 52 factorial cancel, that is 1 upon 0 factorial. Now 0 factorial is nothing but 1, hence 1 upon 1 is equal to 1. So ultimately we can prove any rule of NCN is always equal to 1. If NC8 is equal to NC6, we need to find out what is NC2. Initially it is given that NC8 is equal to NC6. We will simplify this equation and will find out the value of n first. Again we know the formula, NCR is equal to n factorial upon r factorial into n minus r factorial. It's given as NC8 is equal to NC6. So n factorial upon 8 factorial into n minus 8 factorial is equal to n factorial upon 6 factorial into n minus 6 factorial. Now in the numerator n factorial we will keep it as it is. Now this 8 factorial we will split up to 6 factorial, that is 8 into 7 into 6 factorial into n minus 8 factorial as it is, and in the right hand side again n factorial as it is, 6 factorial into, now this n minus 6 factorial we will split up to n minus 8 factorial, that is n minus 6 into n minus 7 into n minus 8 factorial. Now this n factorial will get cancelled from both the sides. Besides this 6 factorial will also get cancelled. This n minus 8 factorial and n minus 8 factorial will also get cancelled. So we have 1 upon 8 into 7 is equal to 1 upon n minus 6 into n minus 7. That is 8 into 7 is equal to n minus 6 into n minus 7. Bigger number would be n minus 6. Hence n minus 6 is equal to 8, that is n is equal to 14. Now by using this n we need to find out the value of NC2, that is 14C2. So we'll use again the same formula, NCR is equal to n factorial upon r factorial into n minus r factorial. So 14C2 is equal to, now n is equal to 14 and r is equal to 2. So 14C2 is equal to 14 factorial upon 2 factorial into 12 factorial, that is 14 into 13 into 12 factorial upon 2 into 12 factorial. Now this 12 factorial will get cancelled. So 14 into 13 divided by 2, that is 13 into 7 is equal to 91. A box contains 5 different red and 6 different white balls. In how many ways can 6 balls be selected so that there are at least 2 balls of each color? Now first of all we will write down the given information very carefully. How many balls are there? There are 5 red balls and 6 white balls. So red balls is equal to 5 and white balls is equal to 6. Now what we need to do is we need to select 6 balls in which at least 2 balls of each color should appear. So how many total possible combinations will be there? In first case we can select 2 red balls and out of 6 remaining 4 will be white balls. Now in the condition it is given that at least 2 balls of same color. So we can also have 3 red balls and 3 white balls, and we can also have 4 red balls and 2 white balls. But we cannot have all 5 red balls, because in that case then there will be only one white ball, and our conditions say that there should be at least 2 balls of each color. So ultimately there are 3 cases: 2 red balls and 4 white balls, or 3 red balls and 3 white balls, and 4 red balls and 2 white balls. So number of ways for this selection. Now in how many ways 2 red balls we can select is 5C2 plus 4 white balls, that is into 6C4 plus 3 red balls and 3 white balls. So out of 5 we can select 3, and out of 6 we can select 3 white balls, and 4 red balls. So out of 5 red balls we can select 4 red balls, and out of 6 white balls we can select 2. And all these conditions we need to add because of the sum rule. So ultimately number of ways for this selection will be 5C2 into 6C4 plus 5C3 into 6C3 plus 5C4 into 6C2. Now 5C2 into 6C4 is equal to 5 factorial upon 2 factorial into 3 factorial into 6 factorial upon 4 factorial into 2 factorial plus 5C3 is equal to 5 factorial upon 2 factorial into 3 factorial into 6C3 is equal to 6 factorial upon 3 factorial into 3 factorial plus 5C4 is 5 factorial upon 4 factorial into 1 factorial into 6C2 means 6 factorial upon 4 factorial into 2 factorial. Now after simplification we get 10 into 15 plus 10 into 20 plus 5 into 15, that is 150 plus 200 plus 75 is totaling up to 425. So there are 425 ways in which we can select 6 balls, so that there will be at least 2 balls of each color. A polygon has 44 diagonals. Find the number of sides. Now there is a formula for number of diagonals of a polygon, that is NC2 minus N. So number of diagonals of any polygon is equal to NC2 minus N, where N denotes number of sides of the polygon. Now it's given as there are 44 diagonals. So NC2 minus N is equal to 44. Now we'll simplify this expression. What is NC2? NC2 will be n factorial upon n minus 2 factorial into 2 factorial minus n is equal to 45. Now we will split n factorial up to n minus 2 factorial in order to remove the factorial sign. So n factorial is equal to n into n minus 1 into n minus 2 factorial upon n minus 2 factorial into 2 factorial minus n, and minus 44 is equal to 0. So this minus 44 we will bring to left hand side. So what we have is n into n minus 1 upon 2 minus n minus 44 is equal to 0. Now LCM of denominator of left hand side is 2. N into n minus 1 is equal to n square minus n minus this 2 into n is 2n, and this 2 into 44 is minus 88. So we have n square minus n minus 2n minus 88 whole divided by 2 is equal to 0. That is n square minus 3n minus 88 is equal to 0. This 2, if we shift it to right hand side, then it will become 0. Now we can factorize this quadratic equation. N square minus 3n minus 88 is equal to 0 as n square minus 11n plus 8n minus 88 is equal to 0. We can take 11 common, n into n minus 1 plus 8 into n minus 11 is equal to 0. That is n minus 11 and n plus 8 is equal to 0. So n is equal to either 11 or minus 8. But now in our problem, what is n? N is a side of polygon. So we need to discard this value of minus 8 because sides of the polygons cannot be negative. Hence, how many sides of that polygon will be there? That is 11 sides will be there, and when there are 11 sides, number of diagonals will be equal to 44. You can put the value of n in this formula and you can verify whether it's coming as 44. In a village, there are 87 families, of which 52 families have at most 2 children. In a village, there are 87 families, of which 52 families have at most 2 children. In a rural development program, 20 families are to be helped, chosen for assistance, of which at least 18 families must have at most 2 children. In how many ways can the choice be made? How many total families are there? There are total 87 families. Now, out of these 87 families, there are 52 families which have at most 2 children. That means these 52 families can either have 0 children, that is no children, plus 1 children, plus 2 children, because it's given as they have at most 2 children. Now, how many families need to be chosen? 20 families need to be chosen, and there is a condition that at least 18 families have at most 2 children. Now, this word at least is important. Out of these 20 families, at least 18 families have at most 2 children. Hence, such 18 families can be selected in 52C18 ways. Now, how many families are there? 87. So, remaining families are 87 minus 52, that is 35. So, if we are selecting 18 families from these 52 families, then out of 20, remaining 2 families need to be chosen from these 35 families. So, in first case, we can have a combination of 18 families from 52 and 2 families from this remaining 35 families. Now, in the question they have asked us as at least 18 families are there. So, we can have 19 families or 20 families from this 52 families. So, once we are done with 18, we can either select 19 families from this 52 and remaining 1 family from 35 families, or we can select all the 20 families from this 52 families. So, ultimately, we need not select any family from the remaining 32. So, total number of ways for selection is equal to 52C18 into 35C2 plus 52C19 into 35C1 plus 52C20 into 35C0, that is 1. As in 35C0 is equal to 1. You can keep this expression as it is. Now we'll see few problems based on combination of permutation and combination. Out of 7 consonants and 4 vowels, how many words of 3 consonants and 2 vowels can be formed? Now, we will write down given information first. Out of 7 consonants. So, how many consonants are there? 7 consonants. And how many vowels are there? 4. So, we have 7 consonants and 4 vowels with us initially. Now what we need to create is, we need to create a word with 3 consonants and 2 vowels. Now these 3 consonants can be selected from these 7 consonants in 7 C3 ways, plus this 2 vowels can be selected from this 4 vowels, that is in 4C2 ways. So number of words with 3 consonants and 2 vowels can be selected in 7C3 into 4C2 ways. Now here what we have done is, we have just selected the consonants and vowels to create the word. So you just have a shuffled or jumbled collection of letters, and now from these letters you need to create the words, that is 7C3 into 4C2. So if we simplify this, 7 factorial upon 3 factorial into 4 factorial into 4 factorial upon 2 factorial into 2 factorial, that is 7 into 6 into 5 into 4 factorial upon 4 factorial into 3 into 2 into 1 into 4 into 3 into 2 factorial upon 2 into 2 factorial. So we have 7 into 5 into 4 into 3 into 2 factorial upon 2 into 2 factorial. So ultimately 7 into 5 into 4 into 3 upon 2 is equal to 210. So there are 210 ways of selection. Now in order to form the word, we need to arrange these 210 letters. Now in how many total places are there? 5. That is 3 consonants and 2 vowels. That means we have 5 places and 5 letters. So number of ways of arranging these 5 letters is 5 factorial, and we know that 5 factorial is 120. So total number of arrangements, that is total number of words, is equal to, now this 210 into 120, that is 25,200 words we can create out of these 3 consonants and 2 vowels. Understood? In these kind of problem, we need to combine both the concepts of permutation and combination. Permutation is for arrangement of the letters and combination for selection of the letters. Moving to next problem. How many 4-letter words can be formed using the letters of the word failure so that F is included in each word and F is not included in any word? Now in the word failure, how many letters are there total? There are total 7 letters. Now out of these 7, what we need to do is, we need to first select 4 letters, because we need to create the words of 4 letters. So total number of ways in which we can select 4 letters is 7C4, that is 7 factorial upon 4 factorial into 3 factorial is equal to 7 into 6 into 5 into 4 upon 4 factorial into 3 into 2 into 1, that is 35. Now once you have selected these 4 letters, you need to arrange them in order to form the word. So total number of words will be 35 into 4 factorial, that is 35 into 24 is equal to 840. Now there is a first condition, in how many of these words F is included in each word. Now F is out of 7. Now we just have 6 choices, because in each word we need to include F. So out of remaining 6 letters, we just need to pick 3 of them. So 6C3, there are 6C3 ways of selection of the letters. So 6 factorial upon 3 factorial into 3 factorial, that is 20. Now these 3 letters plus the letter F can be arranged to form desired word. So how many such words we can make? That is 4 factorial. Now total number of words will be 4 factorial into 20. Now here why we have taken 4 factorial is because in the question it is just asked that f should be included in each word. There is no fixed position that it should be at the start, it should be at the end. So it is, we can make any combination of f. So ultimately total number of arrangements will be 4 factorial, and hence total such words are 4 factorial into 20, that is 480. Now there is a second condition, that in how many of them f is not included. We have already know that how many total words are there, that is 840, and we also know that in out of 840, in 480 words there is f is always included. So words in which f is not included is equal to total number of words minus word in which f is included, that is 840 minus 480 is equal to 360. "18 guests have to be seated half of on each side of a long table. 4 particular guests desire to sit on one particular side and 3 others on the other side. Determine number of ways in which the sitting arrangement can be made." Now how many guests are there? There are total 18 guests. So let's suppose you have this rectangular table. So 9 can be seated on one side and 9 guests can sit on another side. Now there is a condition that 4 particular guests desire to sit on one particular side. So suppose these 4 guests want to sit only on this side and remaining 3 want to sit only on another side. In a particular arrangement, say a group of 4 guests is sitting on side A and group of 3 guests is sitting on side B. Now in how many ways these 4 guests can sit on side A and 3 guests can sit on side B is 9p4 into 9p3, that is 9 factorial upon 5 factorial into 9 factorial upon 6 factorial. Now out of 18, let's say 7 guests have occupied their places. So remaining 11 guests can occupy the remaining 11 chairs in 11 factorial ways. Hence total number of arrangement will be 11 factorial into 9 factorial upon 5 factorial into 9 factorial upon 6 factorial. So in this video we have seen practice problem on permutation as well as few problems on advanced concepts of combination of permutation and combination. If you have any doubt, do let me know in the comment box. We'll try to answer your queries in upcoming videos. Thank you.